Hello everyone. In this lecture, we will discuss about Rolle's theorem and Lagrange mean value theorem. So here I am Dr. Bharat Kesari Swami, lecturer in mathematics. Let's start. So what is the statement of Rolle's theorem? Let f be a real valued function continuous on the closed interval ab, differentiable on the open interval ab, and suppose f of a equal to f of b, then there exists at least one c belongs to ab such that f dash c equal to 0. In other words, if I say in words, if a differentiable curve start and end, suppose here, okay, check here first, if be a differentiable, if a real valued function, and it is continuous. What are the conditions? It must be continuous on the closed interval of AB, first thing. Next is it is differentiable on open interval of AB. And suppose f of A equal to f of B. Okay, so first is continuous on the closed interval of AB, differentiable on open interval of AB, then f of A equal to f of B. Then there exists at least one C. There exists at least one C such that f dash c equal to 0, such that f dash c equal to 0. So in words, if a differentiable curve starts and ends at the same height on an interval, it must have at least one horizontal tangent inside. What does it mean? So if I draw, see here, if I draw a curve, suppose this is your A, this is your V, and this is our curve, and this will be f of A, and this point will be A, f A, okay, and this point will be B, f of V. Now they are at same height, so f of A equal to f of B, is not it? Then the statement says that there will be some or at least one C here inside A and B, so that your f dash c, that means f dash c will be 0. So if f dash c will be 0, so f dash c means what? F dash c means it's a slope. F dash means slope, and f dash c means slope at point C, is not it? A slope of the curve at point C. So it will be at C. This is a point. What is this point? CF of C, and this f dash C will represent the slope of the tangent. And since it is equal to 0, since f dash C equal to 0, so that means slope is equal to 0. See, if it is slope equal to 0, and we know that slope of x-axis is also 0, and so it will be parallel. It will be parallel to x-axis. Your tangent will be parallel to x-axis. So we say that it must have at least one horizontal tangent inside. This is what it mean, one horizontal tangent. Okay, now come to next page. So what is the explanation? You can say one by one. So first point is continuity on AB ensures the functions attains a maximum and a minimum, which is extreme value theorem. We know that if it is continuous, it must have a maximum or a minimum. Then differentiability on a B allows us to speak about slopes at interior points, And if f of a equal to f of b, then either f is constant or f is not constant. If it is constant, then f dash equal to 0. Or if not constant, it achieves a strict interior maximum or minimum at some c. So at that point, your f dash is equal to 0. So it's a simple picture that endpoints at same height, car must turn somewhere to connect them. So to connect f of means the point AFA and VFB in the previous figure we see. So there will be a turn, the car must turn. So that causes a horizontal tangent, which causes a horizontal tangent. Okay, now come to next page. The verification and proof. So if f is constant on AB, then f dash x equal to 0. We know that, and we are done. Otherwise, if it is not constant, so by extreme value theorem, it attains its maximum or minimum. Already we have said that. Its maximum or minimum because of the extreme value theorem. Because it is continuous, it must have a maximum or minimum on your interval AB. So since f of a equal to f of b, and f is not constant also. If f is not constant, so at least one of these extreme value, that means your extrema, occurs at some c. Is not it? Because your f of a equal to f of b. This is your f of a equal to f of b at same height. F of a, f of b at same height. This is your this type of curve. Maybe it may be like this, or it may be like this. Maybe like this. Okay, f of a equal to f of b. This is your a, this is your b. A, b. So f of a, f of b. They are at the same height. F of a, f of b. F of a, f of b. They are at same height. And f is not constant. So if f is constant, there will be a straight line, horizontal line, because all are same at same height. But f is not constant. So at least one of these extrema occurs at some point C belongs to A and B. It may be maximum, it may be minimum. So if C is an interior maximum or minimum, then because f is differentiable at C, we must have f dash C equal to 0, because f is differentiable at that point. So using your Fermat theorem on stationary point, your f dash C equal to 0. F dash C equal to 0. Okay. So next come to the application of this Rolle's theorem. So it is a stepping stone to mean value theorem, because it will help for the derive your mean value theorem, and it is used to show uniqueness and uniqueness of roots and properties of polynomials, uniqueness of roots and properties of polynomials. So one of the example is here, fx equal to x square plus 1. We can verify the Rolle's theorem. So fx equal to x square plus 1 is a polynomial on the interval -1 and 1. So according to definition, if you compare with the definition, so -1 is your A and 1 is your B. This is your A, this is your B. -1 is A and 1 is your B. And fx is your x square minus 1. So we have to check. So what are the condition? It must be continuous on the closed interval. It must be differentiable on the open interval. So because it is continuous, because it is a polynomial, so we know that every polynomial function is continuous. So it is obviously continuous, and also it is differentiable. Is not it? So there is no need to prove differentiability or continuity of the function, because it is polynomial. It is always continuous and differentiable. So we can write f is continuous on -1 to 1 closed interval and differentiable on upper interval. Now we have to check f of a equal to f of b. A is -1 here and b is 1. So we have to check f of -1. So because f of x is what? F of x is x square minus 1. So put -1 here. So it will be 1 minus 1 square. That means 1 minus 1, that is equal to 0. And f of 1 will be what? Your 1 minus 1 is equal to 1 square means 1. 1 minus 1 equal to 0. So f of a, that means f of -1 is equal to f of 1. So f of -1 is equal to f of 1, and that both are equal to 0. Both are equal to 0. So by Rolle's theorem, f dash c will be 0. F dash c will be 0. What is your f dash c here? Fx equal to x square minus 1. So your f dash x will be equal to 2x. Dash x is equal to 2x. So at c, your f dash c will be 2c. So according to Rolle's theorem, that f dash c must be 0. So 2c equal to 0. And if 2c equal to 0, then c will be 0. Is not it? C equal to 0. Now check here that c lies inside -1 to 1. That c lies inside -1 to 1. Is not it? And according to Rolle's theorem, what we say? That c exists, at least there exists c, at least one c exists, in which means in your interval -1 to 1. So your Rolle's theorem verified. Is not it? So indeed f dash 0 equal to 0, which corresponds to the minimum at x equal to 0, because we know that uh, f dash c equal to 0 means it gives your extreme point. Okay, so if I put 0 here, f0, isn't it, f dash 0 is equal to 0, according to, because c equal to 0, so f dash 0 equal to 0, 2 into 0 equal to 0, which corresponds to the minimum at x equal to 0. Okay, now come to another example. Another example is what? Given function is gx equal to sin x. And the interval is given 0 to pi. Okay, so we have to check function is differentiable or continuous, and g of a and g of b, here 0 equal to a and pi equal to b, if I compare with the statement. Now because sin x, we know that in the interval 0 to pi it is continuous. If I draw the graph, you can from the graph you can easily check it is continuous and differentiable, because sine function is differentiable and continuous in the given interval 0 to pi. Now g of 0 is equal to what? Sin 0. So g of 0 means sin 0, because g of 0 equal to sin 0. And g of pi is sin pi. Sin 0 is equal to 0, and g of pi equal to sin pi, and that is equal to also 0. Now it is continuous, it is differentiable, and also g of 0 equal to g of phi. So according to Rolle's theorem, g dash c must be 0. And what is g dash c? So g dash means g of x equal to sin x. So if gx equal to sin x, your g dash will be cos x. And g dash c means cos c equal to 0. So if cos c equal to 0, we know that c equal to pi by 2. And you can check here that C must exist in between 0 to pi, because pi by 2 lies on 0 to pi, in between 0 to pi, and that's why Rolle's theorem verified. Okay, so this is a verification of Rolle's theorem, and this is a quick application. You can see here, quick application. Suppose a differentiable function h satisfies h a equal to h of b, h of a equal to h of b. If h of a equal to h of b and h dash x greater than 0 for every x belongs to a b, so Rolle's theorem gives a contradiction, because we know that h of a equal to h of b means your h dash x must be 0 if it is differentiable and continuous. Your h of a equal to h of b, so your Rolle's theorem says that your h dash x equal to 0, but if it is greater than 0, there will be contradiction. So that type of h does not exist, cannot be, that type of h cannot exist. So this is very useful to prove your uniqueness of the results. Now, what is the summary of this? Interior stationary point exists when endpoints are equal. Is not it? F of a equal to f of b, and c, f dash c will be 0. That is your interior stationary point, and that will exist when endpoints are equal. Then secondly, it relies on continuity and differentiability assumption. And third, it is useful as a foundation of the mean value theorem. It will help for the mean value theorem, and it will help derive mean value theorem to derive mean value theorem and the uniqueness of the proofs. Okay, next come to Lagrange mean value theorem. Okay. So, what is the statement of the Lagrange mean value theorem? Let f be continuous. Same thing, same type of statement. F is, okay, let me explain. F be continuous in the closed interval of AB. Next, differentiable on the open interval of AB. Then there exists at least one point C such that f dash c will be f of b minus f of a divided by b minus a. F dash c, in case of Rolle's theorem, f dash c equal to 0. But here it will be f of b minus f of a divided by b minus a. Okay, in case of Rolle's theorem, there was another condition, f of a equal to f of b, but here that is not the case. Only closed interval, in the closed interval it is continuous, it is as it is in your Rolle's theorem, and differentiable on the open interval, it was also in the Rolle's theorem, but the condition f of a equal to f of b is not here. Okay, it is not here. So if it is not the case of the Rolle's theorem, but in case of Lagrange theorem, it is continuous, it is differentiable, and then there exists at least one C belongs to a B such that f dash C equal to f of B minus f of A divided by B minus A. So what does it says that the slope of the tangent means here f dash C, we know that f dash C is the slope of the tangent, and if I check, you can say that this is your A, this is your B, isn't it? This is your A, this is your B, and if it is like this, if this is like this, f of A, this is your AFA, and this is your BFB, okay, BFB. So the f dash c means your slope of the tangent. If I draw this tangent, it will be equal to the slope. That means that will be equal to like this, or you can write like this. Okay, this is your AFA and BFB, and the slope of the chord joining AFA, the chord joining AFA and BFB. So what is the slope here? We know that slope is f of b minus f of a. divided by b minus a. F of b minus f of a divided by b minus a. So that's why this is the means your slope of the curve at C. Slope of the curve at C will be equal to f of b minus f of a divided by b minus a. So that's why it is written here, the slope of the tangent at C equals to the slope of the line, second line joining AFA and VFB. That means your chord joining AFA and VFB. That means your slope will be f of b minus f of a divided by b minus a. Slope of the line joining these two points is what? F of b minus f of a divided by b minus a. So your f dash c will be that. This is your Lagrange theorem says. Now come to next page. What is the explanation? The second line represents the average rate of change of f over AB. The tangent line at some C must be parallel to this second line. Already I have told that because this type of curve will be there. This is your f of a, this is your f of b. Okay, again I will draw this like means this is your f of a, this is your f of b. Is not it? F of a, let's suppose it is f of b. So if I draw the line, this is your slope of the tangent at C point. This is your A, B, C. This is your tangent of the slope, and it will be parallel to the point joining AFA, and F of B. This is your VFB, and this is your AFA. Okay, now now follows from Rolle's theorem. By defining a helper function, we will check your G means already we can check means we can prove your Rolle's means your Lagrange mean value theorem using Rolle's theorem. How? See here, just consider the function gx, fx equal to, suppose consider this function gx equal to fx minus f of b minus f of a divided by b minus a into x minus a. Suppose g of x is this. Now you can check here g of a. What will be g of a here? G of a equal to put a in place of x. This is your f of a minus f of b minus f of a, f of b minus f of a, there will be b minus a into x minus a. We have to put a in place of x, so a minus a. So a minus a will be 0. This will be 0. So if it is 0, then only g of a will be equal to f of a. So your g of a equal to f of a. Value of g of a equal to f of a. Now again find g of b. G of b will be what? In place of x, just put b. So it will be f of b. Is not it? F of b. Then minus f of b minus f of a divided by b minus a into b minus a. Okay. So b minus will be cancelled. Now f of b, what will be result? F of b minus f of b plus f of a, and f of b minus f of b cancelled, so f of a will be final result. That means g of b will be equal to f of a, and g of a is also f of a, so both are equal. So g of a equal to g of b, and since fx we have given fx is differentiable and continuous, so the sum or difference of two continuous function and differentiable function are also continuous and also differentiable. So that's why gx is also differentiable, gx is also continuous, and also g of a equal to g of b. So that's why Rolle's theorem will be applicable. So if Rolle's theorem is applicable, so your g dash c will be 0. G dash c will be 0. So if g dash c equal to 0, then according to from this helper function, we suppose means in our considering function, what will be g dash? If gx equal to, this is your gx. So if g dash will be what? G dash will be f dash and f dash, then derivative of x minus a means what? Only 1. So that will be f dash minus what? F dash minus f, this is constant, so f of b minus f of a divided by b minus a. And what will be g dash c? Just put c in place of x, so g dash c will be g dash c will be f dash c minus f of b minus f of a divided by b minus a. Now g dash c equal to 0, that's why this term will be equal to 0. And if you solve for f dash c, so f dash c will be f of b minus f of a divided by b minus a, and this is nothing but your Lagrange theorem. F dash c will be equal to f of b minus f of a divided by b minus a. So this is how we can prove your Lagrange mean value theorem using Rolle's theorem. Now come to the verification. Already I have already we have computed all these things. Is not it? G of x equal to this, and g of a equal to g of e, it is continuous, Rolle's theorem exists, g dash equal to 0. Already we have computed all these things. F dash equal to f of b minus f of a divided by b minus a. Okay, now come to some application and example. So using this, we can use to prove inequalities and monotonicity, error estimation, and fundamental theorems in calculus. Okay, so this is applicable in different proofs of the inequalities and monotonicity and error estimation, and different fundamental theorems in calculus can be derived using this Lagrange mean value theorem. Now for verification of the Lagrange mean value theorem, we can check from this example that suppose fx equal to x square, and here interval is given 1 and 3, and we know that fx equal to x square is a polynomial function, so it is continuous, it is differentiable, and what will be f dash c? Okay, what will be f dash x? F dash x equal to 2x. F dash equal to 2x. Now just see the average rate of change, means f of b minus f of a. What is a b here? A equal to 1, b equal to 3. So what will be f of b minus f of a? So f of 3 minus f of 1 divided by 3 minus 1. And since f of x equal to x square, so f of 3 will be 3 square, that means 9, and f of 1 will be 1 square, so minus 1 divided by 3 minus 1, that is equal to 2, and 9 minus 1 equal to 8 divided by 2, that is equal to 4. Now just find your f dash c again. So f dash c means f dash x equal to 2x, so f dash c will be 2c, and 2c equal to because it is your f dash will be equal to average rate of change, means that is your 2c will be equal to 4, and if you solve for c, so c equal to 2. Now see, this 2 belongs to what? 1 and 3 belongs to 1 and 3, open interval of 1 3. So in between 1 and 3, 2 exists. So that was your statement of the Lagrange mean value theorem. Okay, so it is very easy. Just we have to remember the conditions. One is differentiability, means differentiable on the open interval of AB, continuous in the closed interval of A. Okay, and if it like this, then f dash c will be f of b minus f of a divided by b minus a. This is the statement, and that c must exist in between a and b. Okay, now this is another function to verify your Lagrange mean value theorem, that fx equal to sin x. Fx equal to sin x. If fx equal to sin x and interval is given what? 0 to pi. 0 to pi. So what will be f dash? F dash will be cos x. F dash will be cos x. And f dash c means cos c equal to 0. Cos c equal to 0. Cos c equal to 0 means what? C equal to pi by 2. C equal to pi by 2. And your right hand side, what is your right hand side? F of b minus f of a, that means f of pi minus f of 0 divided by pi minus 0. F of pi means your f of x equal to sin x, so f of pi means sin pi. That means your sin pi, it will be sin pi minus sin 0 divided by pi minus 0. And sin pi, we know that sin pi is 0, sin 0 is 0, so your numerator will be 0, that will be final answer is 0. So your right hand side is 0, your f dash c, that means cos c equal to, both are equal, we know, that's why cos c equal to 0 and c is equal to pi by 2. So that c belongs to what? 0 to pi. 0 to pi, in between 0 to pi. So that's why that was our statement. If it is differentiable and continuous, then there is a point C where f dash c will be 0. Sorry, f dash c will be f of b minus f of a divided by b minus a. Okay, so we found that C is a point, that is your pi by 2 in between 0 to pi, where f dash c is equal to f of pi minus f of 0 divided by pi minus 0. Okay, so this is the verification of Lagrange mean value theorem. Okay, these are the conclusion of this lecture. First, what we have found, Rolle's theorem and mean value theorem, they are the foundation of differential calculus. And Rolle's theorem what says that it guarantees at least one point with zero slope when the function starts and ends at the same value, because they are at same height. Then at least one point is there where the slope is 0. F dash c equal to 0, that means 0 slope. F dash c equal to 0, that means 0 slope. Next, now mean value theorem, Lagrange mean value theorem generalizes this by ensuring a point where the instantaneous rate of change equals the average rate of change. Instantaneous rate of change equal to, instantaneous change means your f dash c, and average rate of change means your f of b minus f of a divided by b minus a. So instantaneous change equals the average rate of change. So these theorems are essential tools. These theorem essential tools for proving monotonicity, inequalities, uniqueness of solutions, and error estimates. And finally, they are also stepping stones towards deeper result in real analysis. So these two theorems are very important, and they are the stepping stones toward deeper results in real analysis. Okay, so thank you everyone, and again we will meet in the next lecture. Thank you.